5 times 5 is?
25.
Yeah. Hey folks, welcome out there to TN Learn Mathline. I'm Ernie Roberts. I'm your host for this afternoon session. And by the way, this afternoon session is all about specialized segments. So we hope you've tuned in and you got a little pencil, paper, maybe a calculator to go along with us. We're going to have some good times here today also. And also we want to welcome the Bearden High School students from AP Statistics class out there. They're going to be feeding us some questions for the show today. And we'd love to go on the road. So if you want us to come out to your school on the road, we've also done some other schools that way already. We'd love to come out and visit you and let us know. Give us that email, take us email, catch us on Facebook, let us know where we can do and who we need to contact, all that good stuff, and we'll work for that in the upcoming school year, all right? But anyway, thanks Bearden for being with us today, and thank you for tuning in today for TN Learn Mathline. Let's have a good time, sit back, relax, we're gonna do some math, get a calculator, get some pencil, get some paper, bar the doors, we're ready to go, all right? Let's see what we've got going today. What's our topic? On the down slope. Now some of you are thinking, are we going to do straight lines? No, we're going to be doing the growth and decay moments, and we're going down the downside today. So we are going to be taking that growth curve that we've looked at, and we're going into exponential decay today, all right? Whew, sounds impressive? It's going to be fun, all right? So let's see what it's all about, all right? Let's see where we're going here. First of all, there's a formula. There always seems to be a formula, and that's what we want to establish before we go anywhere on this, because it makes life so much easier. So we use a situation here. Last time when we were doing growth, all right, we used simply starting with an amount, and that's what we're going to do today. Same story. And we also picked up what we call a principle, a starting point, if you will, and we did something with it, all right? We took a flat line situation of 1 and we were going to raise it to an amount of time, all right? What we did, however, with a growth, we put a plus a rate, okay, whatever the rate is. Exponential decay, decay means the opposite of growth. So we're going to put a minus. We're going to be losing value today. We're beginning to lose part of our numbers, all right, that we're dealing with. So we're going to put a 1 minus r into the picture. And that r will be a percent change to a decimal, all right? T, we're going to keep that annual or per se periods. This show we're going to be doing with annual decay, all right? And looks like we're ready to go here with it. We will put some problems there. So think about it, guys and ladies, when we look at these things, real world situations, the word depreciation, population decline, things of that nature are going to be coming up and looking at us today. So let's see what we've got going here on this one, all right? First things we got to work at, just let's do an example. And by the way, we're going to use the graphing calculator because it's really got some neat features that help us out on these things, all right? So let's take a look at our first problem we've got for today, all right, here. A computer valued at $1,200 depreciates an average of 20% per year. How much value will it hold after 2, 3, and 4 years? I'm also going to put in 1 year just for the fun of it. But the formula, if you remember, our formula said we're going to start with this amount. By the way, that amount is not how much it depreciates. It's the amount of the value of the computer after the depreciation happens. So we're going to take the principal, and we're going to put that 1 minus r because it's losing value, not gaining. By the way, that's what happens when we buy a lot of these material things that we think we love and enjoy. They lose value. Okay, so if you're making long-term payments on them while you're giving the company more interest and such, going on the uphill, growing, your computer, your car, whatever is going downhill in decline, all right? Now, if we were doing straight line depreciation, we would use a linear function. We're going to use exponential decay, all right, for this, and allow it to, because it's never going to really bottom out completely out of value, but after 20 years, it probably after 4 years it's worthless because computer technology continues to go so fast. It's growing exponentially in how we do. But anyway, growth curve, this time it's the down slide, all right? So let's take a look at this one and use our formulas. 20%, $1,200, and we'll go with 1, 2, 3, and 4, all right? So let's start off first of all with our first situation. We've got $1,200 going in there for P. We're going to put 1 minus, now be careful, be careful. It's not, you got to put the decimal in there, all right? If you put minus 20, I shudder to think what we're going to have happen here. I really do. You want to make sure that decimal gets in there. That would be a rough moment if you don't. And we're going to put it in for, first of all, for 1 year. All right, let's go to the calculator to see how this one's going to work. All right, so let's take a look. We've got 1,200, and I'm going to go ahead and put it in here. 1 minus 20 hundredths, or 0.2 or 0.20, however you want to look at it there. That is going to give us 8 tenths, all right? Because what we're doing, we're seeing the retaining value. So let me go ahead and just put 1 minus there. I will go with the retaining value after a while here. But we're going to put in 2 tenths. There we go. Don't need to put a 0 on there. That's fine. And then we're going to raise that exponentially. Exponentially to the first power. Well, we really don't have to raise it to the first power, but I'm going to go ahead and do it in there just to give us habits and formula practice, all right? So the first year, we've lost a little bit of money. Actually, it looks like we lost 240 bucks, all right? So that's going to give us 960. That's the dollars we've got, all right? Now, what we want to do is see what happens when we have 2 years, all right? So let's see, we got 1,200. Again, everything is the same. Everything stays the same. I'm going to just use 2 tenths there. But this time we're going to raise the exponent to 2. All right, we're going to start with 1,200 again. We see, Ernie, we had 960. Well, again, our formula says we can allow any number of years to work. So we're going to just use the formula, all right? Granted, we could start with 960 and just simply do it principal times 80%, and we would be fine. But we don't want to, we're going to go with the formula, all right? Just hang with me on that. Now, let's go back to the calculator, because I'm going to show you a cool feature that this calculator has, all right? We get there. There we go. If you go back to second, and you press enter, you get a repeat of what we had before the answer came up. Isn't that cool? You get the repeat of the problem. Now, all I want to do is work backwards and change that 1 to 2. And then I am ready to figure out my new answer. Isn't that pretty neat? All right, once again, you go to that second value and you press enter. We're going to come back and do that again in just a second. But now what we're up to is, or what we're down to, I guess we were losing value, aren't we? For 2 years, wow. See what happens? That computer is really, really dropping off in value. Let's go again. Let's take it for a third year. 1 minus 2 tenths. We'll raise it to the third power. Now remember what we're going to do. Go back to the calculator. Let's go back to the calculator. And we're going to hit that second enter. And that's so cool. And we're going to take and cursor back to the left and put a 3 in there. Got it? Press enter. We are now at $614 with a little chump change, 40 cents on that discount, all right? Computer is almost, look, it's almost lost half its value. Almost lost half its value. Pretty close, pretty close. And let's see what happens on the next one. One more time, we're going to do 1,200. Again, raise the problem to the fourth power this time. See where we are after 4 years, all right? So you getting the idea? Let's go hit that second and enter button again. Here we go. Curse backwards, not curse, cursor backwards. You don't curse this thing, it's a good thing. Let's see, put a 4 in there and let's press enter. How about it? $491. And now we got 52 cents. Get excited about that 52 cents. Now we are certainly less than half, all right? And we're heading toward basically about 2/3 of the value, and then it gets less and less each year. It loses a little bit more. And you're basically taking 20% of this and subtracting it each time. So while this first year we lost 240, the next one was not quite 240, and then it was even a little bit less. But folks, it's still a downhill decline. It is down the slope, down that slope, all right? So again,
got a math question? Mathline has answers. Hey, Mathline.
Hey, Ernie. I'm Becca from Bearden High School. How much will a new $24,000 car be worth after an annual depreciation rate of 25% over 5 years?
Ooh, Becca, how much will a new $24,000 car, and that's pretty typical price for a car, be worth after an annual depreciation rate of 25% over 5 years? And that, again, that depreciation rate can vary. Some cars depreciate a little bit less rate, maybe 20%, but we're going to go with 25% because basically in that idea, we try to get our car payments for 4 years. Some people have this tendency to like to go 5 and 6 years for payments. Woo, not a good idea, not a good idea. You're paying a lot of interest, and let's see how much that car is worth. So let's take a look at this problem. Thank you, Becca, and Bearden High School is going to be with us throughout the show today. We're going to use that formula, the amount. A stands for amount, principal times 1 minus our R, and we're going to raise it to the amount of time, how many years. Now also I added another one here. I want us to just, after we do the one for 5 years, we're going to also look at 6 years. And I want you to realize, boy, those of you who are making payments for 6 years on a car, that is totally unwise. I'm sorry, I didn't mean to insult anybody, but it is not wise to do it over 6 years. That's a lot of extra interest, and your car is just going down, down, down every year, all right? So let's take a look at what happened with our value here. First of all, P, remember P is 24,000, 24 grand. That's what you're starting with, all right? So we put in 24,000. We're going to also say 1 minus 25 hundredths, 0.25. By the way, that's going to give us 75 hundredths, 0.75. So in other words, you're basically keeping 3/4 the value each year. You're taking 3/4 of the value again, 3/4 of the value, 3/4 of the value until you finally get down to the 5th year. And it's not going to be very pretty, but that's what this exponential part is. That's where the 5 works for us. That allows us not to have to run through 5 different computations on the calculator. We will go straight to it. Now, I want to go ahead and point out again, we got 24,000 and 1 minus that. We're just going to go ahead and put it in there. 75 hundredths, 0.75. Raise it to the 5th power. And folks, that 5th power is going to give it the effect of saying 3/4 times 3/4 times 3/4 times 3/4 times 3/4. So in other words, we're running that 3/4 over and over through this original 24,000. And it's going to be kind of disheartening when we see where we are. Actually, if we kept just 3/4 to begin with, we would lose 600, how about 6,000 off the first year. So let's see what we've got here. All right, let's go to our calculator. Got 24,000. And we're going to put in, multiply it by 75 hundredths. We're going to raise it up to the 5th power. Hold your breath, folks. Hope everybody's getting that going at home. That's what we're worth. Oh my goodness. Less than $6,000. After 5 years, you are basically less than 25% of what you started, because 25% of 24,000 will be 6,000. So here we go. $5,695. And guaranteed, if you've been paying for 5 years, you've paid a lot of interest on top of it. You didn't pay 24,000. You're probably more closer to 27, 28,000. So you paid out 28,000. You've got I won't say a hunk of junk there, but you've got a bit of a decline, now worth less than 1/4 of what you were originally ticketed for there, what you're originally paying. Wow, that's scary. That's reality math. Not pretty. Now, let's do one more shot here. Let's take it for 6 and see what 1 more year does for us, because I know a lot of people who now hear this advertisement, you can finance for 6 years on your car. Why would you want to? Because it's just losing value and you're paying more and more interest and you're paying payments over and over and over again. Whew, folks, go for 4 years or less. That's my general advice to you. When you're buying a new car or even for a used car, try to get your payments done in 4 years or less, because they get wearing on you and the car isn't going to go up in value. It's not going to be improving. You're paying more money, but you're getting less value for it. So let's go back to our approach here. Let's see, to the calculator. Thank you, guys. Let's go second enter again. Remember that little trick we have. And we have everything waiting for us except the new exponent. Let's go back and fix it. Cursor back to the left. Hit the 6. And here we go. Wow, we are now down to almost 1/6 of the value. Boy, it's a scary thing, you know, this exponential decay. We've got $4,271, and how about we'll put 48 cents on there. Like anyone's going to be interested in that one. You'll probably try to sell that thing for $4,280 or $4,300, something like that. That'll be your blue book estimate right here. But nonetheless, notice definitely dropping, definitely dropping. So Becca, thank you. And let's see what we got our next question coming in from Bearden about.
Hey Mathline, I'm Caleb from Bearden High School in Knoxville, Tennessee. I have a question for you. A farmer buys a tractor for $50,000. If the tractor depreciates 10% per year, find the value of the tractor after 7 years.
Hey Caleb, thank you. A farmer buys a tractor for $50,000, and folks, those are some nice tractors, and there are many of you are going, tractors are worth that much? Yes, they are. They do a lot of great things out there on the farms and the big, huge tractors. The tractor depreciates 10% per year. Find the value of the tractor after 7 years. All right, very practical problem here, all right? So again, we're going to our formula. We're going to our formula. And we're going to use a 10% depreciation rate this time, all right? So we're going to change that 10% to, yes, you got it, decimal and a 10, all right? So 0.10, 10, 1/10, all those great ways of calling it. We're going to find the value of the tractor after 7 years. So once again, A, remember, stands for that amount of what we keep, all right? Not the amount of depreciation, but what is the amount that we end up with at the end. So we've got, we've got this $50,000 tractor. I'm going to put it in parentheses because it's a big thing. That's your P, all right, your principal. We're going to say 1 minus that rate because it's depreciating. Sorry about that. And we're running it for, 7 years. People tend to keep their tractors and such for a long period of time. However, again, remember, just like anything that works in this world, pretty much, real estate, one exception to that usually, real estate can appreciate, not instead of depreciate, but it can appreciate. That means goes up at a great rate if you hit the right places and the right times. But things like tractors, things like cars, things like computers, consumables, so to speak, they lose value, and they lose it usually pretty quickly. 10% is a pretty reasonable rate here, all right? So let's test this out and see what happens. Go to the calculator, guys. Let's see what we've got here. We have, let me clear off this other part first. That was from our last one. We got $50,000. Now 10%, it's not going to go down quite as fast, all right? 10% depreciation, but it's still going to go down. Unfortunately, these things don't go back up. So let's do it at 1 minus, and we know what 1 minus means. It's going to be 0.9, 90%. 9/10, we'll put it in there. Let's roll that in. And again, we're going to run it for 7 years. And we end up with, it's worth less than half of what you started with. $23,914, and we'll give it 85 cents. There we go. That's the decimal right there. So 23,915, let's try it again. 23,000, I can do this, $914. I wanted to go ahead and run it up to the nearest dollar. And I'm going to get that right in a minute. That's the decimal. 85 cents, there you go. So even at 10%, a lot of times we don't think about that. But when we lose 10% each year of what we had, it starts amounting up, folks. It starts to take away. It's not just going to be 10% and you're done. No, you're losing every year, 10% every year. That's exponential decay. Wow. And I said it's about money, but it's also about population. Let's see our next story here.
I am James from Bearden High School, and I have an exponential decay problem for you. A town had 42,000 people 10 years ago. If it lost 3% of its population on average for each of those 10 years, what is the amount of people living in the town now?
Wow, James, thank you. A town had 42,000 people 10 years ago. It lost 3% of its population on average for each of those years. What is the amount of people in the town now? So let's see what this is doing. All right, for each of the last 10 years, we are losing 3%. You say, well, Ernie, that doesn't sound like a lot. 3%. You're thinking 3% of 42,000, but keep in mind you're on the average losing that 3%. So it's a downhill slide. It's definitely a downhill slope. So let's go ahead and write our formula here. P times 1 minus R. We're going to raise that up to T. Now remember, P is principal where we start. R is the rate of decrease in this case. And T is how long, how many years did it happen? Notice that becomes an exponential. That's why we call this exponential decay. A, not the amount of decrease, but the amount that's left over. All right? And by the way, we usually tend to think of when we have people, this may come out with a fraction or a decimal on the end of it. We usually either have a whole person or not. We don't usually just take 1/2 a person and keep them around. All right? So we will look at that decimal and play with it at the end. All right? But let's put in our numbers. We've got 42,000. These are people. We don't have, like I said, we can't take 1/2 a person or 3/4 or whatever. So let's see. We got 1 and we got minus 3%. Be sure you put 0.03 in there. And we're going to run it for 10 times. All right. So James, that's what we're going to do on this. So let's go to calculator and see. There went back our 50,000 we lost there. How about 42 grand? And we're going to take this and we're going to multiply it. Now, folks, I'm going to go ahead and put it in there. 1 minus, and remember that 3%'s got to go to 3/100ths. Be sure you put that 0 in front of the 3 between the decimal. And we're going to raise it to the 10th power and see what happens. Now, like I said, 3% doesn't seem like a lot, but still, this does. You've lost over 12, almost 12,000. Let's say over 12,000, almost 12,000, actually about 11,000, a little chump change, all right? So what we'll do, we're going to say that amount is now at, how about it, 30,000. We'll give them credit for that extra person. But those are persons, all right? That's a population, all right? So those are people, persons, individual, peoples, persons, all those good things, all right? So that's what we're dealing with. So individuals, population, how about that? We'll go back to population. All those P's, love them. And that is an interesting situation because when you hear that towns are declining and the rate doesn't stop, it happens over and over, all right? So let's get one more in here. I think we got one more quick question to come in, and let's see what we got here.
Hey Mathline, I'm Andrea from Bearden High School. I have a problem for you. If I have a car worth $15,000 that depreciates in value 20% annually, how much is it worth after 5 years of depreciation?
Andrea is back to the car worth $15,000. Thank you, Andrea. And we have depreciating in value 20% annually. Okay, so how much is it worth after 5 years of depreciation? Let's take a look at that one. And we've got A, our formula is equal to our principal value, starting point. And this time we're going to do 1 minus 2/10. And we're going to raise that up to the 5th power, all right? So that's our 1 minus the rate. That's our time, how many years we've got. So let's go ahead and put that P in there, and we will go to the calculator. Just a minute. Hang on just a second, guys. 15,000. Let's go ahead and say what that gives us. It's going to give us 8/10, 80%, 0.8, and we raise that to the 5th power. Let's see what we get for that. Andrea, I hate to tell you, but I think that car is going to go down quite a bit. Let's check it out. We got 8/10. We're going to raise it, wow, up to the 5th power. That's one of those people who bought 5 years. Don't want to do that. And that's what it's worth, my friends. 4,000. We might as well just say $4,915 and a little chump change on the end of it, 20 cents. But that, notice, folks, that's a decline. That's such a decline. That's more than $10,000 off, just a little bit over that. So that's a lot of depreciation. But that's the thing. When you buy cars, once you buy a new car, take it off the lot, it depreciates. It's no longer a new car, and nobody's going to pay new car price for it. And this kind of gives you an idea of what goes on as the years go on. Guess what? It has more wear and tear. That's why we say it depreciates, and it depreciates in a certain manner. Now people say, well, after a certain point it becomes an antique, it becomes worth something. Well, it better be in good running condition, and it better be a well taken care of vehicle, all right? But anyway, that's our story today, a little bit on exponential decay. We hope you've enjoyed it. Bearden High School, thank you for the AP statistics, got that out, AP Stats class, helping us out a little bit with the questions there. Very, very practical math there that you saw today. It affects all of us. It affects all of us, how things depreciate and lose their value. And remember, when you buy cars, vehicles, keep that in mind. Don't throw all your money into a nice car. It isn't going to be worth that much at the end of the cycle of 5, 6, 10, however long years you want to keep it. It goes down a little more each year in value. But thank you for being with us. We are going to be back again next week, more specialized segments through the summer. And you know what? We'll be back again come fall with live call-ins. So those of you who missed that, hang on, we'll be back. And thank you for tuning in today, and we'll see you next week.